15 billion miles from Earth, a machine older than the internet just went completely silent, and nobody on the planet knew why. For 3 days, NASA's most legendary spacecraft simply stopped talking. Then, out of nowhere, it sent back a signal using a radio system it hadn't touched since 1981. This is the story of how Voyager 1 almost died in the void, and how a handful of engineers pulled it back from the edge using technology from before most of them were even born. Let's set the scene first, because you need to understand just how insane this spacecraft's journey has been. Voyager 1 launched in September 1977, back when disco was still playing on the radio and nobody had heard of a personal computer. It was built to fly past Jupiter and Saturn, take some photos, and call it a mission. Nobody expected it to still be running today. Yet here it is, decades later, the single farthest human-made object from Earth, cruising through interstellar space at over 38,000 miles per hour. It has left the solar system entirely. It is now flying through the space between stars, sampling particles and magnetic fields that no other spacecraft has ever touched. But being the oldest traveler in the universe comes with a price. Voyager 1 is falling apart, slowly, piece by piece, and every year the team at NASA's Jet Propulsion Laboratory has to make brutal decisions about what to keep running and what to shut off forever. Its nuclear power source loses a little more energy every single year, and there is no way to refuel it. So one by one, instruments have been switched off just to keep the spacecraft breathing. It's like watching someone slowly turn off the lights in a house room by room, just to keep the heating on a little longer. The spacecraft runs on a radioisotope thermoelectric generator, basically a chunk of decaying plutonium that converts heat into electricity. When Voyager 1 launched, that generator produced more than enough power to run every instrument on board at once. Today, decades later, it produces only a fraction of that original output. Every watt of power has become precious currency, and the mission team has to decide which pieces of 47-year-old hardware are worth keeping alive and which ones have to be sacrificed. It's a slow, quiet countdown that's been running since the day this spacecraft launched, and everyone on the team knows exactly how it eventually ends. Now here's where things get strange. In October, the mission team sent a routine command to Voyager 1, instructing it to turn on one of its internal heaters. This wasn't some random experiment. The spacecraft's onboard computer circuits are so old and so exposed to decades of cosmic radiation that they're literally degrading from the inside. Engineers hoped that a controlled dose of heat might help repair some of that damage through a process called annealing, basically giving worn-out circuits a chance to heal themselves. It sounds almost too simple to work on a machine built in the 70s, but in space, sometimes the oldest tricks are the only tricks you've got. Except this simple command triggered something nobody expected. The heater instruction apparently drew more power than the spacecraft's onboard systems were comfortable with. And Voyager 1 has a built-in safety mechanism called a fault protection system, essentially an autopilot designed to protect the spacecraft from itself. When that system senses something dangerous, like a power spike it doesn't understand, it takes drastic action without asking permission from Earth. It just acts, and in this case, it activated in a way that would end up cutting off communication with our planet entirely. Think about the distance we're talking about here. Voyager 1 is so far away that a single signal traveling at the speed of light takes over 22 hours just to reach it. So when the mission team sends a command, they don't get an instant response like you would texting a friend. They send it, and then they wait nearly 2 full days just to see whether the spacecraft even received it, let alone whether it responded correctly. Every single decision made during this crisis had to account for that brutal delay. There's no live troubleshooting session out here. There's no rebooting and immediately checking if it worked. Every move is a slow, tense gamble across the void. To put that delay into perspective, imagine sending a text message and then having to wait an entire day just to see 2 little check marks appear. Now imagine your entire job depends on getting that message right the first time, because if it's wrong, you don't get to just send a quick follow-up. Or you wait another full day to even find out something went wrong, and then you have to devise a completely new fix, send it, and wait again. This is the reality of deep space engineering. An entire career built around extreme patience and calculated risk, where a single mistyped command could mean losing contact with a piece of history forever. On October 18th, the team on Earth noticed something was wrong. Voyager 1 wasn't responding to their commands the way it should have. When they went looking for its signal, they discovered the spacecraft's fault protection system had quietly lowered the rate at which it was sending data back, likely to conserve whatever power it had left. That alone made the signal harder to detect, like trying to hear someone whisper from across a stadium. But the team managed to track it down, buried in the noise picked up by NASA's Deep Space Network, the massive array of radio dishes that talks to spacecraft all over the solar system. For one moment, it looked like they'd caught the problem in time. And then, on October 19th, the signal vanished completely. Voyager 1 had gone dark. The team believes the fault protection system triggered not once, but multiple times in a row, eventually shutting down the spacecraft's primary transmitter altogether, the X-band system that had been humanity's main lifeline to this spacecraft for nearly 5 decades. Just like that, the connection was gone. Now imagine being one of the engineers on this mission. Some of them have worked on Voyager for years, some for decades. The spacecraft isn't just a piece of hardware to them anymore. It's basically a colleague that's been sending updates from the edge of known space since before most people alive today were born. And suddenly, it stopped talking. No warning, no goodbye message, just silence, stretching out across billions of miles of empty darkness. Here's the twist that makes this story almost unbelievable. Voyager 1 actually has a second transmitter on board, an old backup system called the S-band transmitter. It's weaker, it uses way less power, and it hadn't been used since 1981, back when Voyager was still cruising past Saturn's rings for the very first time. This system was basically retired, sitting untouched for over 4 decades, a relic from an earlier chapter of the mission that nobody thought they'd ever need again. The team believes that when the fault protection system kept triggering, it eventually switched the spacecraft over to this backup transmitter as a last resort to save power. But here's the problem. The S-band signal is dramatically weaker than what NASA's Deep Space Network is used to picking up from Voyager 1. Some engineers genuinely weren't sure if they'd even be able to detect anything at all. Picture trying to catch a whisper from someone standing on the opposite side of an entire ocean. That's roughly the scale of difficulty we're talking about here. So the team scrambled. They reconfigured the Deep Space Network's giant antennas, some of them wider than a football field, to specifically listen for this old, faint, almost forgotten frequency. And they waited. Remember, every command and every response takes nearly 2 days round trip out here. This wasn't a 5-minute fix. This was days of nerve-wracking silence, checking data, adjusting settings, and hoping that somewhere out in interstellar space, a 47-year-old machine was still listening. And then, finally, it happened. The engineers picked up a signal, a faint, weak, almost ghostly transmission coming through on that ancient S-band frequency, confirming that Voyager 1 was still alive out there, still functioning, still fighting against the odds after everything it had been through. It felt less like fixing a machine and more like receiving a message from a ghost that had chosen to speak again. The team sent a follow-up transmission to confirm the connection was stable, and days later, they got the response they were hoping for. Voyager 1 was back. But let's be honest with each other for a second, because this isn't the first time. Voyager 1 has scared its own team half to death. Back in late 2023, the spacecraft started sending back complete nonsense, a repeating loop of ones and zeros that meant absolutely nothing. For months, engineers had no idea what was happening. It felt like watching someone lose their ability to speak, still alive, still present, but unable to communicate a single coherent thought. It took a team of engineers, some of them pulled out of retirement because they were among the only people left on Earth who still understood Voyager's ancient 1970s computer architecture, to finally crack the case. The culprit turned out to be a single corrupted chip in the spacecraft's memory system, a tiny piece of failing hardware billions of miles away that had thrown the entire mission into chaos. If you're new here, this channel is all about the wildest true stories from space exploration and the edge of human knowledge, so make sure you like this video and subscribe so you don't miss what's coming next. What makes this whole saga so wild is the sheer contrast between the stakes and the tools available to solve them. We're talking about one of the most sophisticated interstellar missions in human history, sending back genuinely groundbreaking data about the space between stars, and yet it's being kept alive using troubleshooting techniques that would feel more at home in a computer repair shop from the 80s. There's no sending a technician to fix it. There's no replacing a broken part. Every fix has to be executed remotely, through code, through patience, and through a signal that takes almost a full day just to arrive. And every single time, something like this happens. The same haunting question comes up among the team. Is this the moment Voyager 1 finally goes quiet for good? The spacecraft's power supply keeps shrinking every single year, and at some point, probably sometime in the next few years, there simply won't be enough energy left to keep any instruments running at all. Engineers already know this ending is coming. They're not fighting to stop it forever. They're fighting to squeeze out every last bit of science and every last signal before that day finally arrives. There's something almost poetic about it, if you think about it long enough. Voyager 1 carries the famous golden record on board, a phonograph disc loaded with sounds, images, and greetings from Earth, meant as a message to any intelligent life that might one day find it drifting through the galaxy. It was built as a message in a bottle for something else entirely. And yet, here we are, still receiving whispers back from it, decades later, using technology so old that most engineers today have never worked with anything like it in their entire careers. The record includes music from across human cultures, greetings spoken in dozens of languages, and even the recorded sounds of Earth itself, wind, thunder, and the calls of animals. Whoever built that disk back in 1977 never could have imagined that the spacecraft carrying it would still be sending data home nearly 50 years later, let alone that it would still be scaring its own creators half to death with near communication failures. In a strange way, Voyager 1 has become two messages at once, one etched in gold for whoever might find it someday, and another written in silence and static, meant only for the people back home who refused to let it go. Some engineers have spent the majority of their careers on this single mission, watching it evolve from a bold planetary flyby into humanity's furthest reaching ambassador into the unknown. Retiring from Voyager isn't really something most of them talk about, because the mission has become part of their identity. When this spacecraft eventually falls silent for the last time, and every model suggests that day is coming within the next few years, it won't just be the end of a project. It will be the end of a relationship that some of these engineers have maintained for their entire professional lives. So think about what actually happened here for a second. A machine built in 1977, currently sitting outside our entire solar system, went completely silent for 3 days. And the fix wasn't some cutting-edge breakthrough or a brand new piece of technology. The fix was reaching back into the past, dusting off a 43-year-old backup system and hoping it still had one. More whisper left in it. And somehow, against every reasonable expectation, it did. Every time Voyager 1 goes quiet, there's this collective held breath across the entire mission team, because nobody truly knows if this will be the time it doesn't come back. And every time, so far, that stubborn little spacecraft has found some impossible way to answer one more time. It's been talking to us. For nearly 50 years now, from farther away than any human voice has ever traveled, and it's still not quite ready to stop. Maybe that's the real reason this story keeps grabbing people's attention every single time it happens. It's not really about the antennas, the transmitters, or the corrupted memory chips. It's about a small, determined machine that refuses to give up, sending faint signals across an ocean of nothingness just to remind us it's still out there. In a universe this vast and this silent, there's something deeply human about a spacecraft that keeps fighting to be heard, one whisper at a time, light years from anything that could ever help it if things finally go wrong. If this story blew your mind even a little, hit subscribe, because there are so many more insane, true stories from the edge of space and science still to come, and you will not want to miss them.